Zener diode. I'll directly change the symbol of Zener diode. How? What is the which alphabet is starting with Zener diode? Z. Make it as Z. Like inverse of Z. You write Z like this. You make it like this. That will become Zener diode. Okay. Yeah. Let me explain you Zener diode. Okay. Listen here. We know PN junction diode. What do we know PN junction diode? How current flows in PN junction diode? In which way? From cathode to anode or anode to cathode? Always keep in mind, in normal PN junction diode, current flows from positive to negative. Current will flow from anode to cathode. Radari, unidirectional. Now let me explain the first definition of Zener diode. Then I will explain the principle of operation. Zener diode is designed not only to conduct current from anode to cathode, but also does flow of current from cathode to anode. It conducts current from anode to cathode, also conducts the current from reverse direction, cathode to anode. It was specifically designed for this purpose only. Means it is a bidirectional device. The normal PN junction diode is a unidirectional device. Now what I am saying, current is flowing from anode to cathode, cathode to anode. It is specifically designed for this process only. Current will move in cathode to from cathode to anode also. It's a bidirectional device having two terminals, anode and cathode. Right? It is specifically designed to operate in reverse, even it is operates in reverse bias condition. It is specifically designed to operate in reverse bias condition. Understandable? Say sir. So under forward bias, it will behave like a normal PN junction diode. What will happen to normal PN junction diode under forward bias? Tell me. This is your IF. This is your forward loop. What is the characteristics? How your current will increase? Your current will increase like this. Yes or no? So your Zener diode will just behave like a normal PN junction diode under forward bias condition. Current increases rapidly. Under reverse bias condition, it has two cases. One is avalanche breakdown, and the other one is Zener breakdown. One is, it falls under two categories. One is avalanche breakdown, other one is Zener. And I have explained what to mean by avalanche breakdown. I hope you have the idea of what to mean by avalanche, what to mean by group of electrons, how avalanche, how breakdown occurs. That is only. When you increase, let me remind you for your purpose, for your better understanding, what I am doing here. What is this?
Negative.
Reverse. What I am doing on x-axis? I am increasing the reverse. What will happen when you increase the reverse voltage? Two electrons will get a velocity. They will get a energy. That two electrons will fetch, will knock off. Knock off means they will break other two electrons from a parent atom. In an atom we will have electrons. They will break those two electrons. 2 plus 2, 4. 4 plus 2, 6. Like that, it will create a bunch of electrons. That is nothing but avalanche. That will break down the junction at a certain voltage. Here, practically it is minus 6 volts. When you increase more than 5 or more than 5.5 or nearly 6, you will get a avalanche breakdown. What do you mean by Zener? Before avalanche, when the voltage reaches near to minus 6, minus 5.5, minus 5.7, breakdown occurs. That is Zener breakdown. When you reach your voltage near to avalanche breakdown, near to minus 6, What is near to minus 6? It may be minus 5.7, minus 5.9. At that time, again breakdown occurs. That is Zener breakdown. Understandable? As simple as it is. Zener diode works in reverse bias condition also. Means current flows in reverse bias condition. But when you take a PN, practically there is a small current. Understandable? Say so. Clear with this. Now let me explain you this operation. How Zener diode acts as a voltage regulator. What is the next topic, subtopic? How Zener diode acts as a voltage regulator. What is that? Regulator. You are increasing the speed of fan or decreasing the speed of fan. You are regulating the voltage. You are changing the AC. You are changing the voltage. Focus here, as simple as it is. Nothing complicated here. What is this? V means input voltage. We have given an input voltage to just change the diagram. This will become Zener diode. We have given an input voltage, certain input voltage. What is RS? A certain resistor. That is connected in series with whom? Series with Zener diode. If you increase this voltage, focus here, as simple as it is. If you increase this voltage, this current increases. Which current? IS, which is available across RS. If this current increases, IZ also increases. Because Zener diode is in series with this. IS increases, IZ increases. But there is nothing happen to load current. We are measuring output where? Where? Here. Parallel resistance. This resistance is parallel. This is not series. Understandable? This is in series. This is in parallel. I am measuring the output here. This nothing will happen to load current. Your output voltage is constant. Understandable? Your voltage, you are maintaining the voltage constant. Again, if you decrease this input voltage, what will happen to this current? Decreases. IS decreases. Means IZ decreases. But your output voltage constant. This is nothing but voltage regulator. Like this, your Zener diode will work as a voltage regulator. Keeping voltage constant. That is nothing but voltage regulation. You are varying the voltage input voltage, but you are keeping the output voltage constant. Like this, your Zener, only Zener diode will work like a voltage regulator. That is specifically designed for this purpose only. The importance of Zener diode is it can work like a voltage regulator. Normal PN junction diode does not work. Only Zener diode works. Understandable? I will repeat it. Zener diode conducts current not only in one direction. It conducts in how many directions? Two directions. Anode to cathode to cathode to anode. Means it was conducting the current in reverse bias also. It is specifically designed for reverse bias condition also. It is also called as breakdown diode. The another name of Zener diode is breakdown diode. You know what you mean by avalanche, what you mean by Zener diode. And you need to apply this. You need to explain this circuit operation. If you increase the input voltage, current across resistance increases. Why we are? Let me ask a question. Why we are connecting a resistor? Always a resistor. You have seen always a resistor across a diode. Why? In flipper you have seen a diode and resistor. In clamper you have seen a diode and resistor. In half rectifier you have seen a diode and resistor. In fuller rectifier you have seen a diode and resistor. In bridge rectifier also you have seen 4 diode and a resistor. Why resistor will be always connected in series or in parallel with diode? Yeah. So resistor, as we know, it will limit the flow of current. It will limit the flow of current. It will protect your device so that most of the current will not go to this, so that it will get burst. That will limit by resistance. It is like a protector. It is like a bodyguard. It is like a salmagan to protect into Zener diode. Resistance. It will limit the flow. If most of the current is flowing here, it will limit it. It will stop it. It will block it. So that your Zener diode is safe. It is in working condition. Clear? Understandable? If you increase voltage, this current increases, this current increases. If you decrease this current increases, this current decreases. Nothing will happen to output. Output is constant. That is nothing but keeping output voltage constant, irrespective of change in the variable